This video, I'm going to try and see if we can sketch graphs without trying to use our memory so much. Is there another way of doing it? So let's explore that. So let's give ourselves something like, I don't know, x squared. So first of all, I'm going to do is sketch by drawing a little axis like this. And I've got to think about what happens at various points. Now I can use my calculator because that could help, but maybe I don't need it. Let's see. When x is a very, very big number, x squared is going to be very, very big. When x is a very big negative number like minus 10 squared is the same as 10 squared. So it's reflected. Now let's consider when it's 0. 0 squared is 0. Boom. So it's in there. Now I've got 3 points. I need maybe 2 others just to see what's happening. So I'm going to choose a lowish value up here. Say 1. 1 times 1, 1 squared. And what about minus 1 squared? Well, again, reflected there. So I get my points, and then my memory kicks in a bit really, because of the last video. Boom. Now, what you need to understand is if the question was minus x squared, then all you've got to do is that minus simply reflects the y values. So it's like you've got a big mirror line along there. Boom. Let's look at another graph and see if we can have the same idea how to answer it. Trying to do this without memory, well, trying to do it as much without memory as we possibly can, because some of us cannot remember very well. So let's start off with x to the power of 3. So what we're going to do here is the same idea. We're going to look at values that are very large and values that are very small. So if I think about a very large value like 10 to the power of 3, gosh, that's 1,000. So it's really high up here somewhere. Now let's consider that same 10 but make it a minus 10. This time, because it's to the power of 3, minus 10 times minus 10 times minus 10 is minus 1,000. So that's all the way down here. Boy, that is low. What about if it's 0? Well, 0 is there. You might think this is a straight line. So that's why I need to have 2 other values. Let's choose a value like 1. 1 to the power of 3 is still 1. Minus 1 to the power of 3 is minus 1. And then that's where you get this number, like this. And of course, once I've got the idea of this, I can use it there. I can say, well, minus x to the power of 3 reflects. So you get this. Right, let's try the other 2 and see if that can help us. There's my x, there's my y. So with these ones, let's remind ourselves, we had 1 over x, didn't we? So, now here's a challenge. When x is very, very, very large, 1 over a very large number is small. Let's think about when x is very, very small, like a half, or a tenth, or a hundredth. 1 over a very, very small number means it's very large. Of course, I need another point. A good one is 1. When x is 1, 1 over 1 is 1. Now that's fine there. But how does that work here? Well, exactly the same, but these are minus numbers. So when it's very, very large in the minus one, like minus 1,000, 1 over 1,000 is 1,000th minus 1,000, it's tiny. And the same there. And then we realise that when it's minus 1, it goes through minus 1. And then finally, let's look at the exponential ones. And then we are done, I promise. Missed out something. What about the minus? Honestly, if it wasn't screwed on, it would fall off. My brain is not great sometimes. Keep forgetting stuff. Minus, reflect. Whee! Reflect. That will hopefully help. Now let's get to the final one. Here goes. So here we're going to look at nice orange colour. So we're going to look now at an exponential, a power. So 2 to the power of x. Now this is important. Again, we're always choosing certain values. When x is 0, we know that's 1. So I know that point. We didn't do x as 0 here, because 1 over 0 is infinity. That's why it never touches. So I'm going to choose another point. When x is very, very low, like minus 10, put it on your calculator. Need you today now. So what I would do is I would literally say 2 to the power of minus 100. Tiny, tiny. Now, I'd say, well, 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. And you can see how it's looking. So there are the different ways I would use in order to label these. Hope it's helped.